I had some real good questions during the break, and I want to share one quick question and answer. It was related to when I'm running these applications, what's actually happening on the Linux side? Is this a single process? Is it an activity inside a process? How is it all packaged up? It turns out there's a tool called DDMS. In fact, within Android, what you're looking at now is called a perspective. A perspective is a group of views. Each one of these little tabs, each one of these windows is a view. So what we're looking at right now is the Java perspective. But there's other perspectives. In fact, we see there's something called DDMS. If I touch DDMS, which is the Dalvac Debug Monitoring System, Dalvac is the JVM, the Java Virtual Machine, what we're able to do is actually look inside this machine as it's running, and right here is actually the list of the processes that are running. So here, let me do this, so you can see the name of the process. I want you to observe down here, com.example.sddoug, this is our process. This is what is hosting our process that we just wrote, this application. Something that's interesting is once you start up an application, it runs until the operating system runs low on memory, and then it kills it. It kills it. So this is actually running as a process, and it will stay running. Notice it hasn't gone away, it's still running. In fact, each one of these is running as a Java virtual machine. Remember our architecture picture? When you start up an application, each application runs as a separate process, and each process has a separate JVM, Java virtual machine. It's often called running in a sandbox. My application, com.example, sddoug here, has nothing to do with com.android contacts or com.android shared storage backup and so forth. All of these, each running in a separate process, each running with a separate Java virtual machine. This is how you have your protection from each app. There's no way my app can get over to this one without going through an approved interface. In fact, that interface is called a content provider. In fact, we'll show that in just a moment. So keep this in mind. It's always, after it's all said and done, you're running as a Linux process. These applications are, after it's all said and done, running as a Linux process. The JVM simply executes the bytecode. The bytecode is converted into C calls, API calls, and it calls down and does whatever it is you're supposed to do. So I had a suggestion, and I might come back maybe in a few months. There was some interest in, could you follow Java from the very top and do a demo that goes from the very top to the very bottom? That is, go show us the Java code, show us the JVM, show us the C library, show us the Linux kernel, for that matter, show the hardware. Go all the way down. Anyway, that's another topic, but remember this DDMS is a really cool tool to gain insight to what's running on your system. So, welcome back to part 2. What we're going to do now is look at XML. What does XML have to do with this? Well, we're going to find out. Most Android apps are a combination of XML and Java. And in fact, that's what we're going to do here. Show both of these together. So what I want to do is begin with the absolute most important XML file, and that's called Androidmanifest. This is the foundation of your application. In fact, when I come over here, we've already got some files open, but notice right here, there's something called Androidmanifest.xml. This defines what your application is. This is the master file that defines what's in your application. In fact, when I double click on that, oops, wrong one. When I double click on the Androidmanifest, we see down here, there's some tabs like manifest and application and permissions and instrumentation and actually the XML file. since this is a programming group, I'm going to go over here to the XML file. Notice it says we've got a manifest. It says which SDK we're using, both the minimum and the maximum. It says we have an application, and it has a single activity. Remember I said earlier tonight, in the world of Android, the activity is one of the 4 most important classes that define this architecture. Activity. When you see an activity, you know it deals with the user interface. So this sets up the activity. It turns out, though, there are others that we can do from here. In fact, what I want to do for this application is add an activity to it. You know, I'd like to have maybe an activity that says about this application. How can I do that? We need to add it to the manifest, because keep in mind, if someone gives you an Android project, if you go to the Androidmanifest first, you'll see the complete scope of how big the project is. Everything has to be there. So what I'm going to do here is go down to the Application tab where it says, here's the nodes. Here's the nodes that make up the application. Right now we just have one, com.example, the main activity. Let's add another one. Let's click on Add, and we're going to add an activity. Let's add an activity to our project. So we say, okay, we'll come in here. Notice this little hyperlink. This is very cool. If I click on the hyperlink, it says, what do you want to name this new Java class? I'm going to call it the About activity. Notice the superclass is android.app.activity. Now when I click Finish, 2 things happen. Number 1, the Java code is generated for us, so we can immediately start executing the writing of Java code. But number 2, the Androidmanifest is modified, so it now knows about this. So here's what I could do. Let's do this. Let's come in here and let's do just like we did earlier. Let's have a button. We'll say equals a new button of this, and I'll say button. Let me set the text. I'll say, how about touch to end. We'll just do something. By the way, you can put multiple lines. This is line 2, and then line 3. So you have multiple lines on that. Of course, the button comes from android.widget. So we come in here. Let's take our button and let's set our on-click listener so that we can respond to this. So set on-click listener. I'll do the anonymous one because I can keep all of my code right here. So on-click listener. And I'm going to do something we've not seen before. I'm going to say finish. So when you click on this button, by calling finish, it says I am finished with my activity. In fact, let's give this a title. Let's set the title for this and just say about this app. So we'll put a title there. So here's our activity. Right, here's our code. We need to add that to our content. So we'll say set the content view of this button. We're going to have the world's biggest button. It'll take up the whole screen. It'll be a monster button. So that's what we've got. But what we want to do is come over here to our manifest and see how has it been changed. Well, look at this. The manifest says not only do we have the original activity, but now we have a new activity. A new activity called About Activity. How do I make this work? Well, check this out. I come over here. Instead of doing the phone dialer, right, we saw how that worked. Let's now do our own activity where we say intent. Intent equals a new intent. Giving of this, we want to say about activity. Get that class, and then we can say start the activity again. So start activity, giving it that intent. Notice how similar these are. Here, we used an intent to start something that we did not write. It was in a separate process. Here, this one is our on. So if I run this, I have added to my project a second intent. And in fact, when you're writing Android apps, for user interface apps, you have lots of activities. And the activities are added, just like we added one here. Watch, when I touch me, notice up here it has our title, SD Jug, for this activity. Now if I touch me, touch to end, this is line 2, this is line 3. Pretty big button, right? Got it. And it says about this app. Of course, if I touch the button, we go back to our other activity. Notice how activities work like a stack. So you push and pop from the activities. So we've done that, and that was with the XML. But you know what? I said there were 4 major things you can add to an Android app, which we've just shown the activity. There's another one called the broadcast receiver. In fact, let me show a thing of that. The broadcast receiver. A broadcast receiver receives broadcast. It turns out the Android device sends all kinds of broadcasts, and you can listen to those broadcasts and you can respond to them. For example, it sends a broadcast when you boot your machine. It actually sends a broadcast saying, "I've booted." It sends a broadcast when it detects the Wi-Fi access point. So here's an AP. Here's the signal string. You want to do something with it? There's literally hundreds of broadcasts. Well, how do you receive one? Well, you do like this. You say, click on Add. I want to be a receiver. I want to receive a broadcast. And we click on OK. And guess what? It says, all right, I'm going to make you a receiver. You need to write some Java code. I'm going to call it my receiver. Notice it inherits from Android.content.broadcastReceiver. So this is real nice that all these broadcasts are coming out. Bluetooth device in presence. I found a Bluetooth device. How you scan for Bluetooth? It sends out broadcasts. I found one. What do you want to do with it? So I'll click Finish. And notice, number 1, we have on receive. So we can receive the broadcast, do whatever we want to when we receive it. And notice our manifest. When I come here to the manifest now, I find not only do I have an activity, I also have a receiver. So an activity is important, a receiver is important if you want to receive broadcast. What's next on our list? One of the features that's always been a strong point of Android, and that is a service. A service is something that runs in the background. No user interface, it just runs in the background. Maybe doing file transfers, it may be connected to a web service, whatever. So here we say, all right, we will create a service, and check this out. Same thing. We have this hyperlink. Click on the name. I'm going to call it My Service. Notice it inherits from Android.app.service. Android.app.service. So I say click Finish. 2 things happen. You see the pattern? We've always got these 2 things. We've got the Java code, and we've got our manifest being edited for us. So here, I see that red underline. I must have some type of error. Well, we know what's nice about Eclipse. We just position the cursor. It says, hey, here's some fixes I suggest. How about add unimplemented methods? Pretty interesting. This binder, other applications can bind to your service. So a lot of the things, let me give an example. Let's say you're writing an Android app and you want to do location, the location manager. The location manager is implemented as a service. Your application binds to the location manager and asks it to send you location updates. Tell me where I'm at. Tell me where I'm as I change my location. And that's how all these services work. You can bind to them and get information. Notice in our manifest, we've got this other item right here. Now we have a service. So if I was starting on a job maybe to support some Android code and I wanted to see how much code it was, if I went right here, they've got two activities, they've got a receiver, they've got a service, there's a fourth one though that's also used with Android, and that is a content provider. Content provider. Now, the same thing, I come here, I say I want to be a content provider, I give my hyperlink, I'll call it my provider. Notice it comes from Android.content.content provider. Now what's a content provider? Well, remember, going back to our DDMS, let me spell this right. Going back to our DDMS, before I go to the Java code, suppose I want to read the contacts. Well, I'm over here, and contacts is over here. This is a Linux process, this is a Linux process, by the way. Each application has a different user ID on Linux. So this is one user ID, this is one user ID, they don't communicate at all. But suppose they need to. Suppose you want to get access to the contacts from this application. The way you do it is you be a content provider. So it turns out the Contacts app can be a content provider. If you're a content provider, you can provide content to other applications. So in our case, what we'll do is say, okay, I'm going to go ahead and add all these methods. And guess what? A content provider can delete content. A content provider can tell it the type of content it's providing. It can insert content. A content provider can query the content, and the content provider can modify or update. Those of you with database experience, you're thinking, wow, that sounds like the typical database operations, right? Insert, delete, query, modify. And that's the model they follow. But it doesn't have to be a database. It can be anything. Notice you access it through a URI. So a uniform resource identifier, of which you, the developer, come up with the syntax, say what it is. The only requirement is a content provider always begins with content : // So on Android, if you want to access some content, instead of saying HTTP : // you say content : // So we don't have time to show each one of these tonight, but the key message I do want you to leave with is that the most important XML file is the Androidmanifest, and these are your four big areas of focus in Android: activity, a receiver, a service, and a provider. But wait a minute, this provider, I wonder what's going on here. Well, the provider actually needs to have a namespace that it provides content for. So let's go over to our, back to our my provider here. And notice, if I scroll down, there's something called the authorities. Authorities. And it has a star, meaning you've got to enter it. And the authorities would be what content are you the authority of? Well, how about org.sd? We'll say hello. So that'll be the authority. If someone asks for this content, we will provide it to them. Only one provider could provide this content, no one else. So now that we've got all that, we've got our manifest, and that's one way you can use XML files. But there's a few other ways. In fact, probably the one most people spend their most amount of time on is the layout. It turns out all of this code that we wrote to generate the linear layout and the text view and the button, you could also do it all using XML and then connect your code to it. So let's demonstrate doing this same demo by doing it with layout. Here's what's interesting, and here's why you might want to use layout instead of writing all Java code. By using XML Layout, you can have different layouts for portrait. You can have different layouts for landscape. In fact, you can have all kinds of different layouts that will automatically adjust to the size of the device. So let's do this. Let's repeat our same demo using our layout. So what I'll do is come over here to my project. So I got some errors here that I think those will all go away. Come on to here where it says Res for resources, and under layout, this is where you can generate your layout. Let's generate a custom one right now. We'll come here and say generate a new layout. I'm going to call it main. I'm going to use a linear layout. Now remember, I wrote the code earlier tonight where I said linear layout, new linear layout, and I edited it. I wrote the code to do that. The great thing is the XML name and the Java name is the same. So if we called it linear layout in our Java code, it's also called linear layout in the XML. So I'm going to say, let's do a linear layout. I'm going to click on next. Notice I can qualify it. And in this case, I'm going to qualify it based on the orientation. So I'm going to say, if the orientation is portrait, notice how it's going to call it layout-portrait, and I'm going to click finish. And this will allow me to do my layout for how I want it to look in portrait mode. Okay, so this is portrait mode. Now what I'm going to do here in portrait mode, let me grab a text view and let me grab a button. Now you should be thinking about the code we wrote earlier tonight. We said create a new text view, create a new button. Well, we've done that here. Right, we've got these lined up right here. And once we've dragged them, we see they're lined up. Here's the structure. We see we've got a text view 1 and we've got a button 1. So let me save that. But you know what? Just for the sake of demonstration, let me also do a layout that's going to be for the landscape. So I'll say, let's do another layout. I'm going to call it main again. Linear layout. Go to next. But this time, for the orientation, I'm going to choose landscape. So I say finish, and of course now I've got mine in landscape. And just to make it easy for us to follow, let's just do the opposite. Why don't we put the button first, and let's put the text second. So we've clearly got two different ones. It'll be easy for us to distinguish. Now from a programming perspective, you want to be able to access the button, both horizontal and portrait, and same thing with the text. How do you do that? You do that by accessing the ID. So notice we have something called button 1 and we have something called text view 1. It doesn't matter whether you're in portrait or landscape, as long as they have the same IDs, you can access those. So let's do this. Let's come over here. I'll go ahead and I'll save everything we've got right now. I'm going to go over to my main code, which we had written earlier. Go back to the main activity. And let's compare and contrast what we would do differently if we use XML for layout. First, I'm going to set my content view. When I start into here, I'm going to set my content view to main. Now, when I set it to main, you're saying, wait a minute. There were two versions of main. There was one in portrait and there was one in landscape. We don't have to specify. Why? Because it picks. It picks based on, are we in portrait or are we in landscape? We just use main. We let it do the picking the right one. But once it's picked the right one, we know that we're going to have both a button and a text view. So let me do this. Let me come here and I'm going to have, let me just put a button. And I think we already had the text view from right here. In fact, maybe I'll keep them all together. I'll have button here. And we got this button that we know we laid out in XML. Right here, when we say set content view, it's going to essentially do the same thing starting from right here. This code, linear layout, create the text view, do all of this. I'm going to just comment the whole thing out. All of this, make sure I get it here. So I'll get this part and also this. This that we did in Java can also be done in XML. Your skill set is important to be able to do either one. Some projects you'll find they do a lot of the lifting in code, other times they do a lot in XML, other times they combine them. That's what we would do here. How do we combine the two? Here's the trick. We say, give us access to the text view. How can we get it? We say find view by ID. We go to our resources and we ask for an ID called TextView1. This is the link. This is the link between the XML and the Java code. It's the ID. Everything you generate has a unique ID. This connects it together. So here we've got access to the text view. We have to cast this because the find view always returns a view. Well, we want to cast it. And just to show that this works, let's say text view. Oh, let's set the text, and we'll say once again, hello, Android Java. And then let's do the same thing with the button. We'll say the button equals find view by ID. Go to the resource, go to the ID, ask for button 1. Okay, we've got button 1. Once again, cast it. So we add the cast to here. And now we'll say button. Let's set our on-click lister. I think I'll just say this, right, since we already have our code set up. And here, by saying set content view, then mapping these, watch what happens when we run our code. So go over here to go to my emulator. So we see hello Android Java at the top. We see the button. We also notice the look of the button looks a little bit different than when we did it under program control. We use kind of the look of the button. And in fact, it still works the same way. That is, I can touch the button and it will get over there and say, bring me over to here. And then I can touch it and I can come back. But watch this. If I rotate, if I do a rotate of the device, check that. Now we put the button on top and we've got the text on the bottom. So we see that it dynamically changed. But from our programming perspective, it still works the same way. If I say here, if I touch button, we'll go over to that other activity. Here it is, touch to end. This is line 2. I'll touch it and we go right back to here. So then I'll rotate one more time. Rotate it. Go back. So the use of the XML files, number one, we've seen it allows you to organize your project into a manifest, right? We've seen that one. Number two, we've seen using it for layout. You can have layouts in landscape or layouts in portrait, and there's lots of other ways. The third major use of XML files is for settings. To set things, to set values. For example, you may want to have a set of strings. And notice your strings, you can put all of these strings into an XML file. We'll just look at the XML. You as a software developer simply will access something called app name. And when you access app name, it will say this. And so this way it's easy to translate everything. You, the software developer, just use this. And every language can translate these as needed. You can do not only strings, but colors. You can do any value you want to put inside this file. Let's say, in fact, let's do a color. Let's go to the values. Let's add an XML file. Notice it says the resource type is going to be values. Let's call it colors. Maybe I'd like to keep my colors inside a file. So here's my resource. Let me choose. I'll go here and say, how about add a color? And maybe the color, I'll just say, call it my color. And let's put a value, let's say hex, FF. Oh, we won't have any red. We won't have any green, and let's use blue. Notice what this is doing in the XML file. It's giving this name called my color, and it's having this value here. How do you use this as a Java developer? Well, we do this. We come back to our code. Let me go to our main activity. And let's suppose we wanted to read the text value. Instead of saying hello Android Java, right, this kind of hard codes it. Well, instead we could do this. Go to the text view and set the text based on going to the resource, going to the string, and get, oh, let's say app name. Notice you can access your resources, and the nice thing about this, of course, the translator can translate everything. The same thing with colors. Let's go to text view. Well, let's do this. Let's break it up. We'll say give us a color by going to our resources. So we'll get our resources. We'll then get a color. What color do we want? R.id. What did I call it? My color. Oops, I want R.color.mycolor. So we've accessed that resource, and then I could say text view. Let's set the text to the, set the background. We'll say set the background to this color. So we run our code, and we see that we've defined our resources in the XML file. It pulls them up, and of course we should see now the changes here, both the text and the color. And there we have it. Got blue, and of course the text that was there. So to summarize, we've seen how to do the values, how to do the colors. So when you're writing Android apps, you often put part of the development into the XML. It could be in the manifest, it could be in the layout, it could be in putting the values. We've seen one of the advantages of doing your layout in XML. You can have different layouts that adjust as you rotate your device and as you have different sizes of devices. We also see find view by ID is how you can map from the XML to what you can do as a developer. And we've seen the values, things like strings and colors can also be stored in there. So to as a summary of what we've seen tonight, this was a sample of how we go through the UCSD extension course. It does start on the 29th, and it is online. So if you don't like to travel or something, just like to do it online, you can do that. And what we saw tonight, we started with pure Java code, and you can write apps like that. And we also showed using XML with Java code, which is the more typical case of doing that. The only difference between what we saw tonight and what we do in the class is in the class, we fully cover the service, the receiver, the content provider, and all the other stuff. So with that said, I am done, and I will open it up for questions and answers. You guys were a good group. Stayed with me the whole time. So, yes, question.
When you launched the dialer, so is the dialer a content provider? Could you get back like the number you dialed and store it in your application, or is that the way you would get to it?
Okay, the question, let me reword your question. It's a good one. So the question is, when I ran this application, let's kind of watch. When I touch this button, we go to another activity. Now here it's the one we wrote, but in the one I did originally, it was the dialer. So the question is, can you get information, really both ways? Can you send information into the other activity? Can you get information back? And the answer is yes. Now does the dialer provide the phone number back to you? I don't know off the top of my head, but it could if it wanted to. In fact, guess what? The way you send information from one activity to the other and get information back is through an intent. So you can actually package up information into an intent, call the number. For example, what you can do, you can actually have the dialer show an actual number by sending it in the intent. The content provider is a separate path when you just want to get content. It's a good question. Was there another one over in this area?
Yeah, I wanted to ask if you cover Xamarin.
So what?
Xamarin. It's well, there is a small company trying to bridge development between Android and iPhones using Mono.
Okay.
Oh, I wonder.
So
if
have
you
I
cover-
used that?
Yeah,
Let me broaden your question. I think the question is really, are there other alternatives to doing development related to Android? What I showed you here was the native Android development tool. If you go out there, there's a lot of startups and other companies building platforms that allow you to develop an app that will target not just Android, but perhaps iPhone. Really, those would be the two biggies, but maybe others as well. And there are a number of platforms that do that, but I don't cover those. I tend to focus pedal to the metal native platform. That's not to say there's not a place for the other platforms. PhoneGap is a popular one for particularly if you know HTML. If you're an HTML and JavaScript, PhoneGap might be pretty good because you can write into what you're familiar with, and then it will go down to the native, either Android or iPhone or whatever the next one happens to be. So there's certainly options of doing that. But in all of the courses I teach, both on the iPhone side and the Android, you always have the most power by going native to the platform. The market is so big, there is room for everybody. There's plenty of room for everyone. Yes?
Just a comment here, you could have also used for the on-click listener. You could have also defined it in the XML as well.
It's a very good suggestion. Notice what's the comment being made is that there was an alternative way I could have done this. I actually started to do that when I was, but let me, your suggestion is really good. The comment being made is instead of doing it like this, instead of putting my code here in the on-click listener like I'm doing here, the comment being made is I could have gone to my layout. Let me go here. I'll choose my, let me choose this layout. And I'll just do it with the XML so you can see exactly what we're talking about. We could do Android on-click. And what I can do with the on-click is I can say, for example, do button. And what this will do when I click, it's going to look for a method called do button. So here it is in landscape. Let me also put this actually in my other one as well. So we had both landscape and portrait. It's interesting you asked the question because I started to do that and I thought, well, I would have to edit both of these files. And so I decided just to do it under program control. But let me, still, this is an important concept. So let's show it here. I'm going to paste the same thing here. Come to the button. So the idea is when you touch this button, it's going to call this thing called do button. So I go to my main activity. Notice down here we have a public void on click right here. And in fact, when I run this, we should get the exact same results. Let me pretend I've edited this. Again, I want to be clear. What I've done is instead of doing this, setting the on-click listener in code, I have set it in the XML. Okay, we're setting it in the XML, and actually, here I'm calling it do button. I need to call it the same thing here. I really need to call this. I'm gonna do it just to keep these separate. I'm gonna have a public void do button, and a view is passed into this. And what I'll do is put this here. Okay, so yet another alternative way of doing this. So you could really argue there's three ways of handling buttons. You could do an anonymous inner class. You could extend the activity to be a handler for the click, or you could do it in XML. So now I'm doing it in XML. When I touch it, I should get the same thing, and we did. So lots of choices. Okay, any other questions? Yes?
Do you have an XML just for the portrait and landscape share the same one?
Yes, you can. The question is, can you have a single layout for both portrait and landscape? The answer is yes. In fact, here's where that is at. It turns out, when we look at the layout, by default, if I had not put the landscape and the portrait, it always pulls from here. So it will get, the default is simply called layout. I thought I would go on and show how you can specify, but you can go the other way as well. So use the same thing for both. One more question.
Are services processing?
Question is, are services processes? Turns out a service is just like an activity from a perspective of it's packaged inside a process. In fact, even though in our, let me go back to the manifest. In our manifest, we saw that we had an activity, we had a receiver, we had a service, we had a provider. All of these run in the same process. They're all packaged in the same process. There's a subtle thing about a service though. A service has a little higher priority than an activity. So when it comes to a low memory situation and it's starting to decide what goes, it would take out activities before it takes out services. Not only that, you can set up your service where it will automatically start back up if it should end. So an activity, a service is considered more mission critical, right? There's something going on in the background than say just a user app. Okay, we're done. Thank you so much. You're a great group.
Thank you very much, Norman. Appreciate it.